So nice to see so many familiar faces here. The one common denominator I find through all these talks is a concern with culture, a concern with community and culture, and I'm no different than the rest of you in that my focus is maybe a little bit on a different kind of culture. Nell touched on it a little bit, but I'm more interested in moving the focus toward the animal world and the plant world, the non-human culture. And I think the nature has a lot to teach us in this respect. After all, it's the most expert entity in information retrieval, information healing, information storage, information transmission. Nature's been doing this for eons. And what can we learn from that? So a lot of my recent work has been trying to go back to the fundamentals of the way a nerve works. Now here's a diagram of a neuron, such as you might find in our bodies. And these are the properties of the neuron. First of all, it either fires completely or not at all. In that sense, it has a digital characteristic. The second quality is temporal summation. It can be made to fire by triggering one dendrite receptor repeatedly over time. So this blue area is the receptors and the dendrites, and you take one of those little branches and you keep banging on it repeatedly, and eventually it's going to cause the neuron to fire. It can also cause it to fire with something called spatial summation by triggering several of its dendrite receptors simultaneously or virtually so. So if you trigger it from a number of places, more or less at the same time. Notice I say more or less. It doesn't have to be identical. In this way, it's different from the digital world that we know in our computers where timing is critical. Signals have to arrive precisely at the right time in order for the computer to work. Nature is more forgiving in that. It can give and take in terms of when those signals arrive. And then finally, latency. It takes a while for the nerve impulse to go down to the other end of the nerve cell. And we call that latency. And finally, refractory period. Once fired, it rests a while before it can respond to stimuli again. So these are the basic qualities of a nerve, and I wanted to make an artificial nerve using chips. So this is a kind of block diagram. First of all, you have the equivalent of the sensor, the dendrites, with the excitation inputs being all those little branches that you see. Then you have the latency, the delay it takes for the signal to transfer, and finally at the very end, a pulsar which then sends out the signal to the next neuron, which links through using electrochemical principles and triggers or not triggers the next neuron. Also, you have inhibition inputs that come in that can inhibit, or by changing the threshold of the sensor, make it more difficult to fire the neuron. And this turns out to be very important because other neurons are going to inhibit this neuron. So you put all these things together in chains and networks and so forth, and you start to create very rudimentary kind of phenomenon. And this is what I've really been interested in. Now here's the actual circuit I came up with, and I don't expect most of you to understand this, but you can see up in the upper left-hand corner the dendrite inputs, and then there's a thing which is triangular, which is basically the sensor part of it, and then you get that little rectangular block, which is deals with the latency period and also with the little pulse that comes at the end. And essentially, this is a very cheap circuit. There's no computer in here. There's no Arduino. There's basically 50 cents worth of electronic parts, so you can make this thing very cheaply. The only thing is you got to make a lot of them. And so, whoops, it went twice. Okay. I have a shaky hand, so it takes, yeah. Okay, good. So I came out with this little printed circuit, which can be duplicated using the same kind of etching principles that people use to make artistic etchings. And then, by the way, I'm not quite in agreement with Nick on this. To me, the wires have to be aesthetic too. Everything in the hardware has to have its own aesthetic, and I try very hard to do that, maybe not purposefully, but it just sort of happens. But so anyway, you can take this circuit and duplicate it over and over and over and over and over again, hundreds and hundreds of times, and then you have all these neurons, which then can be connected together and create a kind of rudimentary cockroach sensor system or something like that. So just one last thing. I brought this board in. It's a prototyping board, and on this are 3 of these Neuromimes. You see the good old Arduino up in the corner. That's the thing that triggers the beginning of the chain, but after that they've been hooked up. So this one is hooked up as a temporal summation neuron, and this one is hooked up as a spatial summation. My words are escaping me. Spatial, what's it? And then finally, you get this one that has a reduced threshold. And once I plug this in, you can see the impulses traveling through the neuron network. So it's a very crude beginning, but at least it gives you some idea of the direction I'm playing with. I don't know how this is going to lead to art. I really don't. I never worry about these things. I follow my curiosity, and if it leads to art, fine. If it doesn't, I'm happy as well. Thank you very much.